Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be doing some work in QuickSurface. We're going to talk about building geometry, in this case, an engine bay cover for this Fox Body Mustang. So this was sent to me by a subscriber. This is a car that he's building, and he wants to design 3D printed covers that block off certain areas in the engine bay. So with the understanding that he's going to 3D print them and use double-sided adhesive to stick them in place, knowing that it's basically just going to be a smoothing process. So in this video, we're going to focus on kind of some basics to go through and create something like this. Not likely going to be a fully detailed model, and I'm going to talk about a couple of reasons for that because obviously when you're designing something like this, the freedom and the ability to make it how you want it and also to kind of build stuff and test it in 3D, that's all important. So going through the process of making a fully detailed model for something like this that may or may not even be the right shape is probably not going to be super beneficial. So we're going to talk about the process, the tools that we have access to, and I will try to answer some questions about QuickSurface that I've been getting, kind of limitations or nuances between some of the different license levels. All right, so first things first, I'm in QuickSurface 2025 Lite today for this. Now, recently I did a video with QuickSurface Personal 2026, and I'm going to talk a little bit about the difference between Personal, Lite, and Pro in this specific aspect. So first, what we're talking about is going to be just a thickened version of a 3D printed cover that matches geometry, in this case of a Fox Body engine bay. It could be whatever you're trying to match, but the workflow that we're going to talk about is going to be cleaning up the mesh, creating an auto freeform that is going to represent a surface that we can use to cut the body, and then we are going to basically create a cut body. Now, again, some nuances here that we need to talk about that are important. There are limitations to doing this in QuickSurface. Now, if you are looking at QuickSurface Personal, the main limitation that we're going to have, well, a couple of limitations. There's no auto freeform, so building a version of the firewall or the section that we want is going to be a very manual process. That's not a bad thing. You can still do it, but there's not like a one-click button to get a surface that you can use to trim that. The second thing is that there is no ability to import or export solid bodies. QuickSurface Personal is meant for personal users that are scanning with the end goal of 3D printing something just for themselves, not a commercial tool. With that, there are a lot of features that are built into QuickSurface Personal that some of them aren't in Lite. But the Lite version does have the ability to import and export CAD data. And that's going to be important to us because we are going to need to export some of this, work in Fusion, and then bring it back in to double check. All right, and so the main difference or things that we see is like in the surfacing tools, if you go to, let's go over here. If I try to take this surface and thicken it, that is a Pro only feature. And so there are some different features like, trying to build this thickened surface that we can't do in Lite. We could do in Personal, but we can't export it as a CAD model. You could export it as a mesh model if you could do everything that you wanted to do here directly in QuickSurface. So that's why we're in Lite today, because it's kind of where most people are likely at, and the ability to import and export CAD is going to be important to us. So the first step in this process is going to be to create a version of the firewall that has only the features that we want the auto freeform, or only the areas that we want the auto freeform to use to create. And we also need a version, or we potentially need a version that has a cleaned up top of the shock tower or the strut tower. And mainly that's for building out the freeform body because it's going to roll up and over that geometry. And so while it can be done without that, it is helpful to get rid of it. So the first thing that we need to do is we need to copy this or duplicate this mesh so that we can begin messing with it. Now there's two real ways that we can do this. We can right click and duplicate, which is what we're going to do. The other way is to actually go into scan data and run like a reduce polygons command, and then you can keep the original mesh. Something to keep in mind when you're running this command is that a model like this is not a great representation of how close or how accurate we are. All right, so the original model didn't have a ton of polygons. I mean, it's a big part, physically a big part. And so having 700,000 triangles for such a large part means that there's a lot of variation in the angles between those triangles. So, for example, if we just look at the firewall here. So what we're seeing in this color is that we've got large sort of flat sections, and then we've got like highs and lows, and they're right next to each other. So these triangles, we've got these like divots and these bumps in them. As we reduce this down to, let's say, 50%, then we're going to see a whole lot of craziness, right? So this is a lot of variation. It tells us we're 42% intolerance. But overall, like if we look here, there's a lot of green between all these triangles. And so this is telling me that really what we're seeing here is we're getting a smoothing out of the mesh, and the new version is a lot smoother, but the original version has a lot of noise in it. And so what we're seeing is a deviation from that original mesh, but it doesn't necessarily mean that we are going way far away in terms of tolerances. So it's something to keep in mind. And if we keep the original mesh on and we say, okay, what we have now is we have a copy. All right, so we could duplicate the original, work with it at full 700,000 polygons, or we could do a little bit of work like reducing the number of polygons, and then use that option to copy it. Basically keep the original and then save the duplicate. Either will work fine. If you've got a really dense polygon count mesh and you want to reduce it to make it easier to work with, then just use reduced polygons. The next step in this process is for us to go through and isolate the parts we're interested in, and also get rid of any details that may be a hindrance to what we're doing. So we're going to edit the scan, and I want to start getting rid of stuff. So I'm going to turn on select through. I'm going to come over here, and I'm going to be using this freehand selection, which is basically allowing me to just draw. I'm going to get rid of where the AC lines come through the firewall and go all the way up to the cowl, and then just delete. Now you'll notice that some weird stuff going on in here. This typically happens when we've got essentially like automatic hole filling. Let's see if I can rotate this around so we can get rid of it. I'm going to turn off select through, and I'm going to try to just isolate that. And what we're trying to do is get it so we've got more than one mesh. So we're going to go to this individual meshes, select that one, keep only that. And now you can see, oh, the select through got me. That happens. So what I'm going to do is select this and fill it. It doesn't matter because I'm not snapping to that area, but ideally, again, you got to be real careful with select through because it can bite you. All right, the other thing I'm going to get rid of, I don't really need anything in front of that. Again, I'm going to go back and just keep that. I don't really need anything below where typically a frame rail would be. I know it's a unibody, but in general, the frame would be. I don't actually really need anything up here either. So anything above the seam in the firewall, the cover is going to have to kind of roll down under that. So what I'm going to do is I'm going to get rid of, let's say that. The more that we can get rid of and clean up, the better it's going to be when we try to use auto freeform. So that's a pretty isolated area. Again, I want to keep that, get rid of all those kind of little pieces. I also want to get rid of this spike right here. So this was likely a screw or something. This time I'm going to use defeature, and defeature will delete it, patch it, and smooth it. Now, if you need to do some additional smoothing, you can select the area. You can try the smooth selected and then clear. There's definitely some weird patching going on back here. I'm not going to worry too much about that, again, because it's not an area I'm interested in. Let's go to the boundaries, select the outside and smooth it. This will help when we go to the auto freeform stage. If you've got Pro, there is a cleanup boundary option when you're doing auto freeform. If you've got light, then you don't have that option. You have to go and sort of pre-clean up the edges before you get in there. All right, so in reality, what we're going to do is we're going to be building a freeform body off of this face and rolling up over the top where basically the strut tower mounting is, and that I want to get rid of that so I've got a better working surface. Now, this is actually pretty tricky. There's a couple ways that we can do this. We can try to use the magic wand brush and then increase the angles. So just kind of work your way around. Because it is, this is a plate that's stepped up over this, but when you scan something like this, it obviously just kind of blends in. So what we're going to do is go around, and then I'm going to use this increase option. And let's check over here. Increase. And then I'm going to delete it. Where did my little menu go? I don't know where the menu went. Anyways, I'm just going to delete on the keyboard. That'll get rid of it. All right. So individual meshes, keep that one. And there's that weird little piece right here. So I'm going to go back to my sort of choose your own adventure brush, delete that, clean that up. And then now I want to go back to, let's go to holes, and I'm going to, let's smooth the boundary. Now we have to be careful because you can see it's rolling up here, which is going to have an influence. So we may want to take it back a step and then smooth it. If we still have that problem, what we may want to do is just delete a couple triangles there. Go back to the hole and see if we can smooth it out and fill it. And so it's not too bad. It's bumped up a little bit, but for what we're doing, it's okay. Again, it's going to be kind of a product of those edges. If you are deleting a hole and you don't have good information around the outside, then it can just be a problem. Now, in reality, we only really need freeform stuff inside of this area, kind of from this face inward. So if we wanted to, we could limit this even more. Let's kind of draw down here and maybe add to it under here. And I'm going to fill this all in. I'll probably do a little bit of work on this piece too. Now I'm taking a slightly different approach than I did the first time I did this. So it might bite me, hopefully not. All right, and then what I'm gonna do is copy and create. And so when we copy and create, now I've got this little piece. We're still working on this. This is the one that we're in the sort of edit scan. You can see firewall aligned 3.1, copy 1, 50%. But now I've got that separate piece that I can clean up and I can use that just for auto freeform. All right, I think this looks pretty good. I'm gonna close that. I'm gonna show this one and we're gonna edit this one. All right, so remember when you're trying to do an auto freeform, that the cleaner the input, the better. So the boundary needs to be clean. We've got to get rid of all these little extra pieces. So once again, select that, keep only that. Boundary, want to clean up. And there's a little bit of stuff going on there. So maybe delete that. I'll go back to the boundary and try to clean it up. And then again, keep just the one body. And with the holes, so this is going to be interesting. If we go into the holes, let's go to this one. When you have something like this, you likely want to expand it because it's doing some weird stuff. That just got nasty. Let's try these ones down here. So if we expand it, yeah, there's this area that was patched. It's got really large polygons. I don't know if that's gonna, yeah, it didn't fill very well. Yeah, it's kind of nasty in there. Okay. What I'm gonna do is I'm gonna delete and defeature that area. I'm going to try to do the same thing over here. Again, because this isn't really needed for what we're doing. And when I say that, what I mean by that is we don't need a surface to cut anything there. I'm going to delete that. We don't need a surface to cut anything there. So I don't care that it's super accurate back there. It was already kind of a weird patch that happened. Now it says there are 3 holes. It's counting that as a hole. Let's try to fill that. And then the whole, it's counting the whole thing as a hole. That's weird. All right, so I'm not going to be able to patch or fill that in, I don't believe. So I'm just gonna have to roll with it. I'm gonna select the outside, try to smooth the boundary, see if I can bring that up. And then again, keep just that one piece. We'll do this one more time. So the more time you spend ensuring that you've got a good input, whether it's the scan itself or whether it's trying to use the freeform tool, it will definitely save you time on the back end. All right, so now we've got this. I'm going to try to run the auto freeform tool. Basic algorithm is all we have available in Lite. The algorithm in Pro is better. It will produce a better result, but this isn't too bad. It's always a good idea to try a lower polygon version. We can turn on analysis and see how close we are. The X part there, which is basically a structural feature that's stamped into the sheet metal. Again, all we really care about is this outside border. That's where we're going to be using it to trim. So that's what I'm really interested in, how close that is. So go to medium. It's a bit closer. Fine is probably not needed, but we'll check it. Well, actually, it's a bit closer where I need it. So I think I'll run with that. So, okay. All right. So now we've got an auto freeform surface. It's got tons of patches on it. Again, the algorithm used in auto freeform for the Pro version is different. It does create better results. In all the cases where I've used it, it's been a better result. So it's just something to keep in mind. Next, what we're going to do is we're going to create a surface. So we're going to do this with manual freeform. We are going to start by snapping here. I'm going to turn snap mode on. And so basically what I want to do is I want to snap all these to the mesh. They should have snapped to the mesh automatically, but I didn't have it on. I had it off by accident. I'm going to split these so you can use S on the keyboard. You also have the option to click this button here. I'm going to do the same thing over here. Turn on my analysis, and basically I'm just going to keep splitting it until I'm happy with the results. You don't want to get too many. There's a little, a couple pockets there. I don't want to go too bad. And then I'm going to double click this upper edge. I'm going to start to pull this up. Again, it's going to snap. I'm going to rotate this around. Let's pull this down. Pull this up over the top. Again, it's going to snap. We'll do it once more. And I kind of want to view this from the top. All right, so I'm going to start to kind of manipulate these. Generally, I wouldn't do this at this stage just yet, but it's going to be spreading out. So go ahead and pull this one, and we'll do one more, and we'll adjust it. And once again, I don't need anything. I don't actually need anything this direction, so I don't need to spend a bunch of time getting that to fit. But it is a good idea just to make sure. All right, now I'm going to go to the smoothing brush, and I'm going to just kind of wiggle it over these areas to see if I can get it a little bit closer. And it looks like I'm probably going to need some more divisions to get this right here, which is okay. So we'll just come in. We can either subdivide the whole thing or, again, divide these up until we're happy with the results. Then I'm going to use a smoothing brush once more, kind of normalize the size of each of these. All right. It looks okay. I could spend more time here. I don't think I really want to divide it up too much more. But again, because we're transitioning around a corner, there's going to be a tighter, basically a tighter bunch of these. But because the mesh is bumped up because of our patch there, it's not going to be super accurate anyways. All right, so now that we have this, I'm going to turn off the tolerance display and just go back to a shaded display. We can also do a zebra stripe and make sure that we haven't really done anything too detrimental. It's hard to see here, but they actually look like they flow pretty well across. All right, and so the next thing is to take this and pull it to the firewall. So I'm going to double click this edge. I'm going to turn snap mode off, and I'm going to go to this option called extrapolate. So with extrapolate on, when I pull this out, it's going to go tangent to the curvature on those edges. Now, you can see here that it's bunched up and it's got all kinds of problems, but this is a good way for us to start taking the natural shape of that toward the firewall. I'm going to use the smoothing brush in the corner. Now, even though it's not dealing with snapping to a mesh, it lets me kind of smooth those out and kind of average their shape. And then from the top, we need to start manipulating these points. So again, snap mode is off. I can start pulling the shape over. As we rotate around, we can see where it's hitting the model. So in a case like this shape really needs to come down quite a bit. And so what I'm going to do is I'm going to take this edge, I'm going to extrapolate and pull that outward. And then I want to start to pull that down. And I'm going to pull these two down as well. And so remember, I want to get it under that seam in the firewall. And so this is going to cause me to start making it twist. And right now I'm not too worried about the shape on this side because we're going to trim it, but I want to get it, basically below that. I probably moved it a bit too much. You can always say close and you can review the shape and go back into the freeform by double clicking. So let's say we need to bring this edge back up, close it, and then just review the freeform. So it looks like it's pretty low overall, which means that I want to take probably both of these and just move them up. And then maybe pull this one up and then take my smoothing brush and kind of normalize it. So we're getting a bit closer. You can see now that it's raised up above that, which means that I need to do just a little bit more adjustment. And I think maybe just pulling that point down, maybe that one down too. All right, so still a very minor bit poking through, but we're pretty close. All right, so we'll do one more edit. Maybe take both of these down just slightly. There we go. All right, so again, what we're trying to do is we're trying to follow the line of the shock tower and carry that into the firewall. All right, so now that we've got it sort of inside where we need up there, we also need it to be inside the shock tower here, which means, again, a couple of more adjustments. So what I'm going to do is I'm going to take this edge, I'm just going to pull that down. I'm going to pull this one down as well. And on the bottom side, I actually want this entire thing to roll inward. And again, the reason for that is I'm trying to get it inside of the boundary where that shape changes. Now I could spend more time and I could try to carry this and raise it up and match the lip there. But again, this is when you have a personal project and you're trying to make shapes like this work in 3D, you need to have, like for me, I would sit there and I would look at the car, and in some cases I might make poster board or cardboard templates and play around with shapes and then maybe even scan those. And so trying to build out shapes where you want them, how they look in 3D, sometimes can be pretty difficult in CAD or if we're dealing with the scan data. So I still do like to get in and make stuff with my hands, whether it's, again, simple cardboard or poster board or something like that. All the sheet metal parts I've made for cars and motorcycles have always started by hand. So poster board and sheet metal, or even sometimes foam and carving. And I feel like, at least for me personally, that helps. That helps me get into the sort of design mindset for that stuff. All right. So what I'm going to do is I'm just going to make some adjustments. I'm going to hold down Shift, pull these up a little bit, maybe this one too, and then just smooth them out. And we'll call that good on that shape. All right. So I'm going to turn the firewall off. I'm going to bring the auto freeform back, and you'll notice that the auto freeform doesn't quite go all the way through. So again, we can manipulate the new freeform body we created. We can go to our surface tools and we can try to extend the edges of the surface. It doesn't really work very well for something like this auto freeform. So in this case, best scenario or solution is likely to take this edge and pull it in just slightly, and then maybe take this upper edge maybe to here and pull that down and in. All right, and now that we've got these two, again, we're working in light, so there are some restrictions on Boolean tools. So if I take both of these and use trim, it's a pro only feature. And this is kind of where we end up getting stuck. So what we're going to do is we're going to export this. So we're going to go to the QS menu, export model, and I will go to QuickSurface, and I'll stick it in here. And I'll just put surfaces in here. So we've got option here to create surface for every freeform face. You do not want to check that because the auto freeform version of the firewall has dozens, if not hundreds, of faces, and it would create an individual surface for each of those. The map Z to Y axis, it's going to be fine how it comes in. The main thing that we want to really know is if we've got step models, we've got IGES models, and how that changes. So what I'm going to do is I'm going to save this as a step. Maybe. Looks like complex data. And I'm going to do the same exact thing as an IGES. And let's go ahead and call this surface IGES just so it's easy. You'll notice that I've got 5 surfaces. I've also got 1 solid, and I just did export model. It should only take what's visible. Let's cross our fingers and hope that's the case. And what I'm going to do is I'm going to upload those. Let's go to where I have them. I should really set up shortcuts for this stuff. And go ahead and upload both of them. Now, anytime you upload or add an intermediate or neutral CAD format to Fusion, those will be without history on. Another thing that's been real annoying since the last update is every time I click the data panel, it minimizes the window, even though the size doesn't change. I don't know if anybody's having that problem or not, but that's kind of been real annoying. But let's go ahead and bring that back up. It is cranking. So anytime we use these intermediate CAD formats, it has to go through and basically convert it to a Fusion file. If you have a mesh and you use insert mesh, then it's not a problem. But if you, again, if you're doing it this way, you just got to sometimes wait a little bit. All right. So with the step file, you'll notice that each surface came in as its own component. All right. So we've got a body here and a body here. That is something that can be a little bit of a pain, and you can drag the bodies up to the top of the design, and then you can right click and remove the components if you want. And so that's possible, and with only 2 surfaces, not a big deal. As you get more and more surfaces, that can become problematic and a giant pain. Also, I will note that this is the first time I've inserted a neutral CAD format into the November update of Fusion, and it looks like it kept history on by default. So that's definitely a change. It's usually off by default. Now, one thing to note about it being off by default, um, you can see here with the IGES file, it ended up creating a ton of individual surfaces. So what I'm going to do is right click and find in browser for that one. I'm going to hide that one. And basically all of the surfaces that we had for that freeform body are now independent. Now, the reason that this is kind of a pain is because when history is off, I have to scroll back all the way up in this thing. If I right click and change to direct modeling and delete the parametric history, we have this validate tool. And so if I go back to this model here and inspect, validate is not there. So this validate tool is something that can check all of these surface bodies. Let's go all the way back down, which go to here. And we can click repair and it'll heal gaps, it'll stitch them together. We can say okay. And basically, this tool can be helpful because a lot of times when you export solid bodies from like QuickSurface, they might come in as individual surfaces if you save them as an IGES. So for whatever reason, the IGES files come in sort of broken apart as independent surfaces. The step files come in as they should, as those no issues are found. Cool. Basically, they come in as independent as they should, like all the freeform stuff's all connected. The problem we have is that they're individual components, so we have to go and kind of move them around if we need to. So I'm going to go back to parametric modeling. But now we've got this, basically this is a group inside of the bodies. I could just drag that up to the top level. It'll get rid of the group. These are all in this component. If you want, you can take them to the top level. If you don't want a component, and you can remove it. Again, it just takes a little bit of kind of finagling things around. All right, but now we've got surfaces in either the IGES version or the step version. We can use the trim tools, thicken tools, whatever the case might be. So what I'm going to do first is I'm going to thicken this, and basically we just need to pick a thickness that we want. Now, what I would say is, if we pick, let's say, minus 10 millimeters, remember that I mentioned it at the start that this is going to be double-sided taped into the engine bay. So if you pick a thicker value like 10 millimeters and then you use the shell tool to say, let's make it 2 millimeters, depending on the curvature, this may or may not fail. Hopefully it doesn't crash Fusion, but we can see it work. All right, so depending on the curvature, you should be able to get away with creating a sort of a part that appears thick and it has enough material on the outside, but is hollow or shelled out, so it's actually thinner. And so that's one way that we can do that. I don't want to do it yet because I still need to trim it with the surface. All right, so now that we've got that thickened, what we're going to do is another annoying thing that has happened in the recent update is it keeps, every time I restart Fusion, it turns off that enable camera pivot. So the orbit isn't actually around that green dot wherever my cursor is when I start rotating. And yeah, whatever. Not a big deal. All right, so now we've got this 10 millimeter thick body. We've got this surface. So we're going to use split body. Shift B on the keyboard if you want it. Body to split, our thicken. Splitting tool is this monstrosity here. I say monstrosity, it's just because that's the nature of converting a freeform body to a NURB surface. Sometimes it is ugly like that. Hopefully it works. Let's see. Let's hide that. And let's hide that. And we are left with our piece that fits the shape. All right, I am going to try the shell. Actually, you know what? I'm going to save this because there is a greater than 0 chance that this might crash Fusion. Some tools you just know going in are going to potentially be a problem. So I'm going to try to do 2 millimeters. And the dialogue is down here for some reason. All right, let's just cue some music, and yeah, it didn't work. All right, since they've added this rounded shell, I have found in a couple cases that rounded shell actually ends up working. But the problem that we have with something like this, and I kind of knew it going in, the problem we have with something like this is actually all of the nuances around the outside where it's matching that scan data. It just really doesn't want to create a shell there. And so it's trying with the smooth. I'm going to let it think for a second, have another sip of tea. And oh, look at that, it worked. Hallelujah. I was fully anticipating it not to work, but that smooth addition to the shell type has saved me a couple times. It doesn't always give me exactly the result that I want. It gives me the one that I need, I guess. I clicked OK. Come on. Kids, this is why you save before you try the shell tool. Now, a little background story. Years ago, I was working on a client project, which was rotoformed 5-gallon like stackable gas can. And I was doing this in SolidWorks, and SolidWorks would not shell the model. It just couldn't do it. And this was very early Fusion days, like 2015. Fusion did it no problem. And so as much as a complaint about, this stuff sometimes, not every program is perfect. All right, there's definitely some weird stuff going on in the corner. But as we can see, we do have a part that appears to be 10 millimeters thick. If I hide the edges, it should fit right in the engine bay. All right. So since we did not move it at all, we brought the surfaces directly from QuickSurface. I should be able to export this as an independent file. I'm going to go to a step file. I'm going to save it in the same location. I'm going to call this one Fusion Export. And then we're going to bring that one back into QuickSurface. All right, so I'm going to hide these. I'm going to go to QS. I'm going to say import CAD. It got me. It got me. All right, let's go ahead and I know what we can do. We can export the mesh and we'll bring the mesh into Fusion. All right, so export scan data. And we'll do fender aligned. And I will go back here to mesh, insert mesh, and we'll bring that in. Okay, so that is unfortunate. That's not a problem I've run into before. Typically, I export CAD data from the light version. I guess I did not realize you couldn't import it. All right, so I'm just going to change this engine bay to, well, let's make it red. And then I will change this one to blue. And there we go. All right, so I guess I didn't realize that you can't import into QuickSurface, import a CAD model. That's a pro feature, but you can export CAD models. Either way, we have a cover that fits into the area. It is 10 millimeters thick, and I'm going to go ahead and change its opacity. Go ahead and set it 40%. So it's 10 millimeters thick, so it's got plenty of spots around the outside that you could put some tape. That little screw or whatever is sticking through there fits inside of it. It should match the shape. Again, it's going to be a giant pain to remove if you tape this thing in, but you could put just a couple of pieces around. And now there is, there's a cover here. You could also, since this is a CAD file, you could also make extra pieces that fit on it, right? So this could be the base that gets put in place, and then you could have a removable cover or whatever the case might be. Now, personally, I don't love that shape, right? Obviously, like I said, the person that's making this, they need to spend some time and be able to actually make the shape that they want to fit in that area. But that is the general process that I would follow. Now, some other just sort of quick notes or points that I would say. if you are trying to make something like this fit to a mesh, whether you're doing it in QuickSurface or Fusion, the higher quality the mesh is in the area that you need. It doesn't have to be everywhere, but in the area that you need, where in this case the cover is going to attach to, the higher quality that's going to be. And it doesn't, again, it's not a density issue, but it is an accuracy issue. So the higher quality that you can get in those areas, the better off you will be getting your parts to fit. So if you're going to scan an entire engine bay in this case, and then you're going to maybe do a secondary scan at higher resolution and do some additional processing in just that area and align them, and then use that as your sort of your final to to work on getting a cover like this to fit, that would be a suggestion for you. All right, so not exactly the video I thought it would be, but hopefully it was still helpful. If you have any questions on this, please let me know. As always, thanks for watching, and we'll see you in the next one.